Hey Derek, this is TJ. I never like to give up on anything, so I'm going to give this one more shot. And I think I already started wrong again. I started holding my finger over the mic again. All right. So I got my finger back off the mic. This is the table I was talking about. So what I do is I take the number of resistors. So I've got 3 resistors. So I make 3 columns. 1, 2, 3. And I'm going to have one last column here for the totals. And then over here I set up these rows, so voltage, current, resistance, and power. And I'll show you how to use it, because this thing could really help you keep from making mistakes. So I'm going to take information that I have that's known on this table. I'm going to put it in, or on this circuit, I'm going to put it in there. So I'm going to start off with R3, and it shows I've got 10 ohms. Now I'm going to come over here to R1, and it shows I've got 20 ohms and 3 volts. So I've got 20 ohms and 3 volts right there. And on this last one, R2, I've got 40 ohms, so I'm going to put that right here on the table. Now you can see that I've got partial amounts of information set up. So now, since I have 2 items right here, 3 volts on one and 20 ohms on R1, I could use these 2 pieces of information and solve for other things. So now I'm going to solve for current at 1. So I'm going to say I1 is equal to E1 divided by R1. So that's going to be 3 volts divided by 20 ohms. And that's going to be, write those values in, 0.15 amps. So that means right here, I'm going to have 0.15 amps. Now, because this is a series circuit, if I've got 0.15 amps here, that means I'm going to have 0.15 amps at all of the locations all the way throughout the circuit, because current stays the same in a series circuit. So I'm going to write 0.15 now all the way across this table. Now I could use 0.15 amps times 40 to figure out my voltage at E2. So I'm going to write that formula up here. E2 is equal to I2 times R2. So that's equal to 0.15 amps times 40 ohms. So that's going to be equal to 6 volts. So I'm going to go ahead and write that on the table right here. 6 volts. Now I'm going to do that again right here. I'm going to say E3 is equal to I3 times R3. So that's equal to 0.15 amps times, what is that again? 10 ohms. Will someone let that dog out before she pukes on the floor?
She's not. She's rubbing her back.
Oh, okay, never mind.
Dad, you already knew that. Don't even.
Never mind my dog, Derek.
You already knew that.
And that's going to be 1.5 volts. So I'm going to come over here and run in 1.5 volts. Now, if you remember Kirchhoff's law, Chris probably taught you about it in class, the sum of your voltage drops in any circuit is going to equal your total voltage. So to write that out, I'm going to say E total is equal to E1 plus E2 plus E3. So that's going to be 3 plus 6 plus 1.5. So that's going to be 3 plus 6 plus 1.5. So I have a total volts of 10.5 volts. And I can write that into the table right here, 10.5. Now, I have 2 different ways to solve for this. I could either first figure out my total resistance by just adding my 3 resistors together this way, or I could take my volts divided by my amps to get it this way. So it's a good way to double check yourself using this chart also. So I'm going to start off, we're going to do it both ways. I'm going to start figuring out my R total by adding these all up. So the formula there is R total equals R1 plus R2 plus R3, which is equal to 20 plus 40 plus 10. So that's going to be 70 ohms. I'm going to write that in right here. And then I'm going to go solve it another way. I'm going to say R total is equal to E total divided by I total. So that's going to be your 10.5 volts divided by 0.15 amps. And that once again equals 70 ohms. So math magic has worked. So now the part that's probably confusing you a little bit is looking at this number right here, this 10.5 volts, and then looking up on the circuit and seeing we've got 14 volts right here in this battery. But if you notice, I've got one battery where this is the positive and this is the negative, and over here I've got the negative and the positive going in the opposite direction. That means that this is a series opposing battery. So, depending on which way the flow is going around the circuit, and I should have looked at that, but I think if I recall correctly, this is a positive right here. If that's the case, that means that this battery has to be bigger than this one to get your 3 volts. So if I've got 10.5 volts here, I'm getting confused here. Give me just a sec. How are you supposed to figure it out if I can't figure it out, Derek?
I couldn't figure it out.
You couldn't figure it out?
No.
I have faith in you.
I couldn't figure it out. No.
Say, hi, Derek.
Hi, Derek. Don't laugh because I'm a genius. Just kidding. Just kidding. Just kidding. That's easy. I'm just kidding. Actually, no, too.
Oh, yeah, I got it now. Back on track. So if the total here is 10.5 volts, and I'm taking 14 volts away from it here, but this has to be the bigger because it's the same polarity as this, that means I'm going to have to take 14 plus my 10.5, giving me a total of 24.5 volts for this battery. If the polarity over here is the other way, if this is positive on this side and this is negative, that would mean that this would be the bigger battery. So in that case, I would take, see if I can write this out, 14 minus 10.5, which would be 3.5. So it all depends on the polarity that they're showing right here where you're doing that voltage reading. So if it's positive and negative, positive on top, negative on the bottom, it's 3.5. But if it's positive on the bottom, negative on top, it's going to be 24.5. So I guess it all depends. I just don't recall looking at your picture what the polarity over here was. But hopefully, if you get yourself set on this, this is really going to save you a lot of messing around. And the same thing here. So now I could use this and solve for powers and power totals. You could use this for figuring out anything now. So I would definitely get used to using these tables if you're having a hard time keeping track of things. It'll save you.